So now we're going to talk about GABAergic transmission, which is referring to the neurotransmitter gamma-aminobutyric acid, or GABA, which is the major inhibitory neurotransmitter in the central nervous system. Notice here that we have glutamic acid as the precursor to GABA that needs to be acted upon by glutamic acid decarboxylase, forming GABA. Now GABA gets transported into a vesicle via the vesicular GABA transporter, and now GABA is stored in the vesicle where it can be released via exocytosis once an action potential travels down to the nerve terminal, activates voltage-gated calcium channels, letting calcium in, facilitating the exocytosis of GABA. Now, the options for GABA in terms of receptor binding is that there could be GABA A receptors, which are ligand-gated chloride channels, which are going to hyperpolarize the cell. Or there's also GABA B receptors, which are coupled to GI. So these are a G protein coupled type receptor. So GABA has two types of receptors, a ligand-gated ion channel and a G protein coupled receptor. The GABA then can be taken back up into the nerve terminal via GAT or GAT, which is the GABA transporter. And inside the nerve terminal, we can have metabolism via GABA transaminase to an inactive metabolite, or the GABA can be recycled back into a vesicle where it can be then stored and released for another round of GABAergic neurotransmission.